Okay, problem 66 wants us to find the area of this trapezoid. So we're going to use the area formula for a trapezoid, and that's equal to 1/2 base 1 plus base 2 times the height. Now, what's interesting here is they gave us a mid-segment. Now, a mid-segment is actually half of base 1 plus base 2. So it's actually like the average of the bases. So this entire portion of the formula for a trapezoid is already been given to us in the form of a mid-segment. It's 40. It's all 40. Okay, say that again. Mid-segment is half of the sum of the two bases, or the average of the two bases. That's what a mid-segment is on a trapezoid. And then we're going to multiply by the height, which is 20, so this is 800. Okay, on to the next problem. Okay, so we're looking at a 1, 2, 3, 4, 5, 6, 7 octagon. So we're going to use, for the area of an octagon, 1/2 NAS. N stands for number of sides. A stands for apothem. And S stands for the side length. So, let's see what we have. Plug in as much as we have right now. You give us the apothem, 36. They give us the side length, which is 41.6. And we have half. They don't give us the number of sides, but we can count them. We already did, and there are 8 sides. And that's enough. That's all we need to do. Plug all that into our calculator, we'll have the answer. And if you plug all that in, you get, I'm not going to do this, you get 5,990.4, I believe. Okay, the next problem wants us to find the area of this shaded region, which is an annulus. So we're going to use the annulus formula, which is the area of an annulus is pi r squared minus pi r squared. Big R is the big radius. So 8 squared times pi, and we have 2 squared times pi. I'm going to do this all in terms of pi. 8 squared is 64 pi, and 2 squared is 4 pi. 64 pi minus 4 pi is 60 pi, and that is the answer for the area of an annulus. Okay, now they want the area of a triangle. So area equals 1/2 base times height. They give us, let's see, they want us to find the height. They give us the area. So we plug in the things that we know. We know area, 576. Half, base of 36. And we have each for height. So all we need to do is solve by getting rid of the half. So we'll take 576, let's multiply by 2, and we'll get rid of the half. Then we'll have to follow it up by dividing by 36. So the height is 32. The next one. Okay. Given the area of a kite, find diagonal 1. They gave us that distance, which we'll call diagonal 2. So the area is 1/2 diagonal 1 times diagonal 2. We have everything we need. 576, half, 36, and d2. This is pretty much the exact same calculations we just did on the calculator. We'll have to multiply by 2, then we'll have to divide by 36, and we'll get that the diagonal is 32. I kind of mixed up my D1 and D2, but the missing diagonal 1, is 32. Okay, we're on to another trapezoid. They give us the area, use the formula for a trapezoid. Put in everything we know. 26 for the area. Half A is base 1. Put in 13. Plus B, we don't know. The other base times the height of 9. Gives us all that. So now we're going to undo it all. So let's take both sides and multiply it by 2. That gives us 252, I believe. Next, we'll have to divide by 9. Gives us 28. So this is 28 equals 13 plus B. We'll have to subtract 13 from both sides and we get 15. So that's the answer for that. Base is 50. And number 72. If they give us the circumference, can we find the area? Of course we can. We use the circumference formula, 2 pi r. Then we'll use the area formula, pi r squared. To find the area, we're going to need to find the radius. We can put in r for radius to calculate area. So from the circumference, which they've given us, we can calculate that. 18 pi c circumference. 2 pi r. We'll divide and solve for r. 2 pi. 18 divided by 2. R is 9. Now, let's take that and put it in for r. The area equals 81 pi. 9 squared is 81. That's the answer in terms of pi. If the area is given to us, can we find the circumference? Of course we can. We're going to have to use the area formula first, because that's what was given. And then we're going to have to take whatever the r value is and plug it into the circumference formula. So let's plug in what we know. They gave us the area. 576 pi. Equals pi r squared. Divide both sides by pi. And you get r squared equals 576. Now we're going to have to undo the r squared by doing the opposite. The opposite of r squared would be square root. So 576. Whoops. Second. Square root 576. So we get 24. So the radius ends up being 24. Take this, put it in for r. 2 times pi. Gives a radius of 24. Gets what value for c? Well, 3 times 24 is 48 pi. I'm going to leave the answer like this. If you wanted to put in 48 times pi, then you could. You would get an answer that would be an approximation. Okay, finally here in number 74, we have the area of a sector. Now a sector formula goes like this. How many degrees? Measure of the arc. Measure of the arc, 360 times pi r squared. So we're going to plug in whatever they give us the area of the sector. So put that in for A. And they want us to find the measure of the angle, or the measure of the arc, which will be the same, because this angle will be the same as that arc. And hopefully they gave us the radius. They did. Yes, 12. Okay, 12 squared is 144. And this is where we are right now. We need to solve that. So let's divide by pi. And then let's divide by 144. So we have 16 divided by 144. Okay? So this is where we are. Point 1 repeating equals n over 360. So we get rid of this divided by 360, we'll multiply by 360. And we get n to be 40 degrees. So that's the measure of the arc. It's also the measure of the central angle.